Hey everyone, welcome back to SyntaxGrid. If you've been following our channel, you know we've already covered descriptive and inferential statistics across 3 dedicated videos. If you haven't seen the earlier parts on descriptive and inferential stats, make sure to check those out on the channel. Now, we're taking it a step further with a deep dive into hypothesis testing. Let's get started. 1. What is hypothesis testing? So, what exactly is hypothesis testing? In simple terms, it's a statistical method used to make decisions or draw conclusions about a population based on a sample. Let's break it down. Imagine you have a claim like, the average salary of data analysts is your assumption. But how do you test if it's actually true? That's where hypothesis testing comes in. We take a small sample, do some analysis, and ask, is what I'm seeing in this sample strong enough to believe it's true for the whole population? That's the heart of hypothesis testing. Let's say a company thinks their new training program doesn't really improve employee performance. The program has no effect. The program does improve performance. You run a test using employee scores before and after the training. If the difference is large enough and unlikely due to chance, you reject H and say, yep, the program works. Types of hypothesis tests. There are 2 types of tests, depending on your research question. Two-tailed test checks if a value is simply different, either higher or lower. Used when you're not sure about the direction of change. Example, one-tailed test, used when you expect a specific direction, either an increase or a decrease. Example, the test type depends on what you're trying to prove, the core ingredients. Now that we know what hypothesis testing is, let's look at the core ingredients that make it work. These are the building blocks you'll use in every test, regardless of the method. 1. Null hypothesis. H. This is your starting assumption. It usually represents no change, no effect, or status quo. Think of it as the default belief you're trying to test. 2. Alternative hypothesis. AKIM. This is what you're trying to prove, that something has changed, or an effect exists. If the data provides strong enough evidence, you reject the null in favor of this. 3. Significance level, alpha. This is a threshold for decision-making, usually 0.05. It represents the maximum risk you're willing to take of wrongly rejecting a true null hypothesis, called a type I error. So, alpha equals sign 0.05 comma. You're okay with being wrong 5% of the time. 4. P-value. This is the actual probability of seeing your data, or something more extreme, if the null is true. We'll go deeper into this in a moment, but for now. 5. Decision rule. Based on the p-value and significance level, you decide whether to reject the null. And remember, failing to reject HT does not mean it's true. It just means you don't have enough evidence. These ingredients work together to make hypothesis testing structured, repeatable, and evidence-based. Step-by-step breakdown of hypothesis testing. Let's walk through the step-by-step process of hypothesis testing. Whether you're comparing means, proportions, or variances, this framework stays the same. Step 1. State the hypotheses. Start by clearly defining the null and alternative hypotheses. This sets up your test, so be precise. Step 2. Choose significance level alpha. Common choices are 0.05, 0.01, or 0.10, depending on how strict you want to be. Lower alpha means less chance of false positives, but harder to prove. 3. Select the right test and compute test statistic. Depending on your data and sample size, choose the appropriate test. T-test for small samples or unknown population variance. Z-test for large samples or known population variance. Proportion test for categorical data. Then use the formula to calculate the test statistic, like Z or T-score. Step 4. Find the p-value. Use the test statistic to find the p-value, the probability of observing this result, if H0 is true. This is where the real evidence comes in. Step 5. Compare p-value to alpha. P. Alpha. Reject. HO. The result is statistically significant. P80 alpha. Fail to reject. Not enough evidence. Step 6. Draw a conclusion based on your test. Make a data-backed conclusion. Always interpret the result in the context of the original question. Let's move on next to P. Imagine you're flipping a fair coin. The null hypothesis says it's 50-50. You flip 10 times and get 9 heads. You calculate, what's the probability of getting 9 or more heads if the coin is fair? That's your p-value. If that p-value is very low, like 0.01, you'd say, this seems too rare to be chance. Maybe the coin isn't fair after all. That's when you reject the null. A p-value is not the probability that HO is true. It's the probability of seeing this data if H0 is true. Complete Python example. 1 sample t-test. Step 1. Import libraries. Import the necessary libraries. NumPy for handling data and SciPy stats for statistical functions. Step 2. Sample data. Define the sample of delivery times in minutes that we'll use for testing. Step 3. State hypotheses. State the null hypothesis, H2, and alternative hypothesis, HEN, based on the research question. Step 4. Perform 1 sample t-tests. Perform a 1 sample t-test to compare the sample mean with the population mean of 30 minutes and adjust the p-value for a one-tailed test. Step 5. Check significance. Compare the p-value with the significance level, alpha equals 0.05, and the t-statistic to decide whether to reject the null hypothesis. Output the t-statistic and p-value and conclude that the delivery time is significantly higher than 30 minutes based on the test results. And that's a wrap on our deep dive into hypothesis testing. We've covered everything from the core concepts to step-by-step Python code examples. For more videos, head over to the SyntaxGrid YouTube channel. You'll find playlists on supervised learning, unsupervised learning, and statistics. If you found this video helpful, don't forget to like, share, and subscribe for more content.